Hey everyone! Today, we're diving into the world of MLOps. Imagine this, you've built an awesome machine learning model on your laptop. It predicts customer churn with amazing accuracy. You're super excited to share it with the world. But here's the catch. Deploying that model into a real-world application can be a real headache. Suddenly your model isn't playing nice anymore. Data pipelines break, dependencies clash, and your once stellar model's performance takes a nosedive. Ouch! This is where MLOps comes to the rescue. It's like the bridge between building cool ML models and actually making them useful in the real world. Just like DevOps revolutionized software development, MLOps brings automation, collaboration, and best practices to the world of machine learning. So whether you're a data scientist tired of deployment nightmares, or just curious about this game-changing field, buckle up. Let's explore the world of MLOps and learn how to build, deploy, and manage ML models like a pro. Now that we know why MLOps matters, let's break down what it actually involves. At its core, MLOps is about creating a smooth and reliable pipeline for your machine learning models. Think of it like an assembly line for your ML project. First, you have your raw data. This data needs to be pre-processed, cleaned, and transformed into a format that your model can understand. This is where data pipelines come in, automated sequences of steps that handle data extraction, cleaning, and feature engineering. Next up, we have the model training phase. This is where your chosen algorithm learns from the data and builds a model. MLOps encourages version control for your code, data, and even the model itself, ensuring that you can track changes, collaborate effectively, and reproduce results. Finally, your trained model needs to be deployed. This can involve creating an API, embedding it into an existing application, or even deploying it on edge devices. MLOps provides tools and strategies for deploying your models efficiently and scaling them to handle real-world demands. But it doesn't stop there. MLOps also emphasizes continuous monitoring. Once your model is deployed, it's crucial to keep an eye on its performance over time. This includes tracking metrics, detecting anomalies, and retraining the model with fresh data to ensure it remains accurate and relevant. Remember the days of frantically searching through folders named model_final, model_final_v2, and model_final_final? Version control systems like Git are here to save the day. In the world of MLOps, version control isn't just for code, it's for your data and models too. Imagine being able to track every change made to your dataset, every hyperparameter tweak, and every model iteration, all in one place. That's the power of version control. With Git, you can easily experiment with different approaches, revert to previous versions if something goes wrong, and collaborate with teammates without the fear of overwriting each other's work. It's like having an undo button for your entire ML project. But wait, there's more! Tools like DVC or data version control take things a step further by allowing you to version your large datasets efficiently. No more clogging up your Git repository with gigabytes of data. So embrace version control. It's your secret weapon for reproducible experiments, seamless collaboration, and a well-documented ML journey. Let's talk about automation. CI/CD, which stands for Continuous Integration and Continuous Deployment, is like having a dedicated team working tirelessly behind the scenes to streamline your ML workflow. Continuous integration is all about automatically testing your code and model whenever changes are made. Think of it as an early warning system that catches errors and integration issues before they snowball into major problems. Continuous deployment takes it a step further by automatically deploying your model to production whenever it passes all the tests. This means faster updates, quicker iteration cycles, and a more agile development process. Tools like Jenkins, CircleCI, and Travis CI are your friends here. They allow you to configure pipelines that automatically build, test, and deploy your ML models with minimal manual intervention. By automating these repetitive tasks, you free up valuable time to focus on what really matters, building awesome ML models and solving real-world problems. Alright, so imagine this, you've trained a fantastic model but it only runs smoothly on your machine. Yeah, we've all been there, dependencies are missing, libraries are incompatible, and honestly, deployment becomes a total nightmare. But hey, this is where containerization with Docker swoops in to save the day. Think of Docker as, well, like a magical shipping container for your machine learning model. It packages your model, along with all its dependencies and libraries, into this self-contained unit called a container. Now this container acts like a mini environment, ensuring that your model runs consistently across different machines no matter the underlying operating system or software configuration. Pretty cool, right? No more of those "it works on my machine" excuses. Docker really simplifies deployment, makes your models portable, and promotes reproducibility. It's kind of like giving your machine learning model a first-class ticket to the cloud or, honestly, any other deployment environment you can think of. Section 6. Cloud platforms, scaling your ML model with ease. So, you've built an awesome machine learning model, and now, it's time to unleash its full potential to the world. But let's be honest, handling the infrastructure, scaling resources, and managing deployments can feel, well, overwhelming. That's where cloud platforms come to the rescue. They're like a playground for your ML projects. Think of platforms like AWS, Google Cloud Platform, and Microsoft Azure as these massive data centers in the sky. They provide on-demand access to computing power, storage, and a whole bunch of ML-specific services. Need to train a model on a massive dataset? No problem. Cloud platforms offer powerful GPUs and TPUs to speed up your training process. Want to deploy your model as a scalable API? They've got you covered with services like AWS Lambda, Google Cloud Functions, and Azure Functions. The beauty of these platforms is that they handle all the infrastructure heavy lifting, leaving you free to focus on what you do best, building and deploying intelligent applications. Plus, they're a cost-effective and scalable solution for taking your ML models from prototype to production. Section 7. Monitoring and maintaining your model, ensuring long-term performance. First off, congratulations. You've successfully deployed your machine learning model into the real world. But hey, the journey doesn't end there. To make sure your model continues to perform well over time, you'll need to keep a watchful eye on it. Think of model monitoring as checking the vital signs of your deployed model. It's all about tracking key metrics like accuracy, precision, recall, and inference time to spot any performance dips or anomalies. Why is this so important? Well, because the real world is constantly changing. The data your model was trained on might become outdated, leading to something we call data drift. Plus, external factors can also impact how your model performs. By setting up monitoring systems and alerts, you can catch these issues early and take action. This might mean retraining your model with fresh data, tweaking model parameters, or even revisiting your feature engineering process. Just remember, deploying a machine learning model isn't a one-and-done task. It's an ongoing process of monitoring, maintaining, and iterating to ensure long-term performance and reliability. Section 8. A practical example. Deploying a sentiment analysis API. Alright, let's bring everything together with a practical example. Imagine you've trained a sentiment analysis model that can figure out whether a piece of text is positive, negative, or neutral. Now, you want to deploy this model as an API that others can use. Here's how we can do it. First, you'd wrap your trained model within a FastAPI application. This app will take text input, pass it to your model for predictions, and then return the sentiment result. Simple, right? Next, we'll use Docker to package our FastAPI app and all its dependencies into a neat little container. This ensures that your API can run smoothly across different environments. Finally, we can deploy this Docker container to a cloud platform like AWS, GCP, or Azure. These platforms offer services that make deploying and managing containerized applications a breeze. And just like that, you've got a scalable and robust sentiment analysis API up and running, ready to process text data and deliver valuable insights. Section 9. Getting started with MLOps. Tips for beginners. So, you're excited to dive into the world of MLOps but not sure where to start? No worries, here are some beginner-friendly tips to help you get going. First, start with the basics. Get comfortable with version control using Git, and learn the fundamentals of containerization with Docker. These tools are must-haves for any MLOps practitioner. Next, explore cloud platforms. Sign up for a free tier account on AWS, GCP, or Azure. Play around with their machine learning services and get a feel for deploying and managing models in the cloud. Then, practice with small projects. Don't try to build a complex MLOps pipeline right out of the gate. Start with something simple like deploying a pre-trained model as an API to get some hands-on experience. Also, join the community. The MLOps community is super welcoming and supportive. Join online forums, attend webinars, and connect with other enthusiasts to learn from their experiences. And lastly, embrace continuous learning. MLOps is a fast-evolving field, so stay updated with the latest tools, techniques, and best practices. Remember, the journey of 1,000 miles begins with a single step. Start small, experiment, and don't be afraid to make mistakes. Happy MLOpsing!